Hi there, my name is Joseph. I work with Sharon Hawkins at RDOT, and today I just wanted to share some neat advances that we've made towards getting LRS tools into our web experiences. So the very first one is super simple. We just wanted a way to be able to click an Arnold line and get the log mile clicked. That's something that for years we've been able to do in ArcMap and ArcPro with the Identify tool, but just haven't figured out a way to do it in our apps. This is really important to us because we have hundreds of employees at the department that they may not have the license or the training to do this in desktop software, but being able to figure out what log mile they're at or suggest log miles for an overlay project or a mowing project or anything along those lines is super helpful. And so I'm excited to be able to allow anyone to be able to quickly figure out what road ID and log mile they're at on a map. The second thing that I'm super excited to share with you is it's a new form of dynamic segmentation that we've developed that works in a web experience. It works in desktop too, but it's more exciting to me that we can do this in an experience in a web app. And so what this allows us to do is instantly, as soon as we change the log mile of a record and update it, we can see right away what that change would look like in a map. I think this is really cool for our maintenance and our field folks to um, be able to verify log miles that what they're entering is actually what uh, that they meant to. Um, if they want a record to go to that intersection, they can see that yes, that log mile will get it to the next intersection. We can also let's take this record. This one starts at log mile 4.5 and make this one end at 4.5. We can close that gap. We could make it end at 4.6. Then I have an overlap flag set up to let me know, hey, um, that record's log miles do overlap with another record's log miles, which isn't important for every data set, but some data sets you want to know right away that the information you're entering in does overlap with other information. And I realized you could often we will run an overlap check later on, a month later, and fix it, but so much better to get that live feedback right away. Last thing I'll do is I'm gonna add a new record. So what we'll do, I'm gonna steal this road ID. Do you have to draw a dummy line first? Then once we hit the create button right away, we can see on the map where that line should be drawn. So super exciting, works a lot like an event layer, but in a web experience, much faster than an event layer because really it's only redrawing when an edit is made to the record. It's not constantly trying to redraw all the records in the table all the time. So a little bit about how I'm doing this. I'm happy to share uh, the arcade code that is behind this, but I don't want to give anyone a migraine. So I'm going to try to just do a high level Google Draw uh, explanation of what's going on behind the scenes. And so the first thing I'm going to go over is the log mile extraction function, which this, first of all, I'll say is it's a arcade attribute expression. And so the first thing that made this possible, Esri in early 2024 came out with a lot of new awesome geometry arcade functions, and this is one of them. So this is where we can take the record that was clicked and we can specify a minimum distance between vertices, and it will take the existing vertices and continue to add new vertices until that minimum distance is met. Once we've done that, we can identify which segment was clicked on that path. Since there's only one record here, we're only dealing with path 0, but we can identify if segment 6 was clicked, then that also relates to vertice 6, and that vertice carries a latitude, a longitude, and a measure value. Something else that was really important that came out recently was this user input profile variable. And that's where we can actually capture that mouse click and use it. Without that, none of this would be possible. Step 3 is just to return the M value of vertice 6 in this case. It's got an X, it's got a Y, it's got an M, and that's what we want to be returned when we click. We want that number returned there in that location. The other function is the kind of new dynamic segmentation function, and it works a little bit differently than traditional dynamic segmentation, which I believe works basically by finding what two vertices the beginning log mile would be between and interpolating. This process works a little bit differently. We filter one record from dissolved Arnold where the road ID matches. So just getting it down from many dissolved routes to one single dissolved route. We do the same thing as last time. We densify it so that there's a vertice at least every 1 meter, but only for that route. And we filter out only the vertices that fall between the BLM, ELM range of our record. So in this case, I'm looking at this road ID from log mile 4 to log mile 8. I only want these vertices. Last step, we just replace the geometry of that record with the new geometry that we've created, this string of vertices. A couple things I want to talk about. I'm actually going to go back. One of the challenges with the log mile extraction was that WebMercator severely distorts distances. And so I had to find a way to do this without using any kind of distances. I think there's a function that will tell you how far down the record, how far down the path you clicked, and it just did not work. The longer the line, the worse the distortion is on the returned M value. And so this was a great way to get around having to worry about lengths and their distortion in this common coordinate system in web apps. And then I kind of just took this Densify idea and applied it to the next problem. And I think this covers the gist of what we're doing. I left out, there's also some error handling where if we don't actually find a matching road ID, we either quit or we store that in an error field. Same thing with the log mile range. If we're not able to find any vertices within that log mile range, we'll just quit, and we have the option to store an error within an error field to let you know that there's invalid log miles. There's those log miles were not found for that road ID. Another thing I left out of just this basic explanation is it's a great idea to use the generalize function, which is the exact opposite of the densify function. So before I return this geometry, I run this and actually get rid of a lot of these unneeded vertices that I only needed long enough to determine which parts of the line were within the range, and then don't actually want to store thousands and thousands of extra vertices. The last thing I'll mention is tolerances. I've noticed several places where the vertice on our Arnold will go out to 5, 6 decimal place precision, and really we only enter 3 decimal places precision wise, and so that can come in to play and be sort of a problem when we're trying to see, well, is log mile 8 less than or equal to this log mile? It's like sometimes visually and practically it is, but it may be 0.0001 off. And so it's a great idea to either round the measure values in these vertices or include some kind of tolerance where we want less than or equal to 8 plus some tiny fraction, so that we can include that little bit extra, a vertice that's an inch away from being included. We want that in there too. So pros, this works in desktop and web applications, which is kind of the original impetus behind creating it. It also works like an event layer, but it's much faster, more stable, because really it's a line feature class. I also like it because it's not going to redraw the geometry unless an edit is made and unless the road ID and log miles still make sense. So just updating Arnold won't cause records to remap or disappear. You can force an edit trigger to happen by calculating a field on the whole table, and it will redraw all the records. But an edit has to happen, and the road ID and log mile have to make sense. If they don't, it's going to draw the record the same way that it always has. And that's where we can store that error to say, hey, the road ID doesn't make sense anymore. We still want it to show up in the same place, the same extent on the world that it always has until it's corrected. The only con I can think of is you must store a dissolved copy of Arnold in the same geodatabase as the line feature class that you're wanting to continually resegment and draw. That's just part of, whereas the log mile extraction is an attribute expression, this is an attribute rule. So this is all occurring on SQL Server at the geodatabase level. And so it can reach across between tables, but it can't reach into a different geodatabase, to a different data store, to do this work, to perform these functions. So I think that's it. I think that's all I have to share, but super exciting. And if anyone's interested, I'm happy to send you the code, or we can meet to discuss how this is working. And this is something that's it's a work in progress. I'm improving it every week, and trying to kind of optimize it and make it better. But I think this is something that will dramatically transform how we do business at RDOT, and I hope that other people find it valuable as well. Thanks a lot.